Somewhere in the universe right now, something exists in a darkness so complete that no light from any nearby star has touched it in billions of years. Not darkness the way a room is dark when the lights go off. Not darkness the way deep space looks from Earth on a moonless night, where the Milky Way still stretches overhead and thousands of stars still burn in every direction. A different kind of darkness, the kind that has no comparison in any human experience. The kind where the nearest star is not light years away but millions of light years. Where the nearest galaxy, the nearest collection of hundreds of billions of stars, is so far away that its light arrives as a faint smear so dim you might not notice it at all. Where the night sky, if you could stand and look up, would be so sparse and so empty that you could stare in every direction and wonder whether the universe was truly as full of things as scientists claim. It exists, this place, not as a theoretical possibility, not as a mathematical extreme case, as a real location in the observable universe with coordinates astronomers can point to, with properties they have measured, with a history that stretches back almost to the beginning of everything. And the question of what it would mean to be there, what it would feel like, if feeling is even the right word, to occupy the loneliest place the universe has produced, is one of the most quietly devastating questions you can ask about the cosmos. Because the answer reveals something about the universe that the usual pictures of glittering galaxies and busy stellar nurseries do not. The universe, in most of its volume, is not like those pictures. The universe, in most of its volume, is alone. This is the story of the loneliest place in existence. And the answer, when you finally arrive at it, is not where you expect it to be. Before we can find the loneliest place in the universe, we need to understand what loneliness means at cosmic scales. Because the word carries human weight that does not translate cleanly to astronomy, and getting this translation right is essential to understanding what we are actually looking for. When a person feels lonely, they feel the absence of connection, the absence of other minds that know them, acknowledge them, share their experience. Loneliness, in the human sense, is social. It is about relationships and recognition. When we talk about cosmic loneliness, we are talking about something different. We are talking about isolation, about the absence of other matter in the surrounding space, about the distance that separates a given location from the nearest concentrations of stars, galaxies, or any structure that breaks the monotony of the void. The loneliest place in the universe, in this sense, is the place that is furthest from everything else. The place that is most isolated from the structures that make the universe recognizable, from stars and galaxies and clusters and the filaments of the cosmic web. The place where, if you existed there, the universe would feel most empty in every direction you looked. And finding this place requires a journey outward, not just from Earth, not just from the solar system, not just from the galaxy, outward through layer after layer of cosmic structure, until the structures become so sparse and so distant that the concept of neighborhood loses its meaning. Let's begin that journey now. Close your eyes for a moment and imagine standing outside at night, in the darkest place you have ever been, far from any city, with a sky so clear that the Milky Way is visible as a band of soft light. Around you, the darkness is real and complete. The nearest town is far away. You are alone in a way that most people rarely experience. Now imagine that the sky above you is not the sky you know. Imagine that the Milky Way, that band of ancient light, the accumulated glow of hundreds of billions of stars, is not there. The familiar constellations are gone. The bright planets are gone. Every star you have ever learned to recognize is gone. The sky is dark, not completely dark. There are still points of light, but they are not stars. They are galaxies, each one a collection of hundreds of billions of stars, but so far away that all those billions of stars blur into a single faint smear. And there are not many of them. In every direction, scattered thinly across the dark, a handful of these faint smears, and between them, nothing. This is the sky as seen from the loneliest inhabited place in the universe. And this place is not a theoretical extreme. It exists. It has a name. People have been trying to understand it for decades, but to reach it, we have to travel outward, step by step, through the layers of cosmic structure that separate where we are from where we are going. Start here. You are on Earth. The nearest star, our own sun, is 150 million kilometers away. Its light takes 8 minutes to reach you. At night, the nearest star visible to the naked eye other than the sun is Proxima Centauri, 4.24 light-years away. Its light takes more than 4 years to arrive. This is the human scale of cosmic loneliness. A star so close it takes light only 4 years to cross the gap. By any measure we will encounter later in this journey, for light years is nothing. The gap between Earth and the nearest star is a rounding error at cosmic scales. Now leave the solar system, move outward through the galaxy. The Milky Way is a disk of stars roughly 100,000 light-years across. For most of its volume, stars are separated by a few light-years on average. There are regions, particularly the dense center of the galaxy and the star-forming regions in the spiral arms, where stars are packed more closely together. There are other regions, the outer halo, where stars are more isolated, separated by tens or hundreds of light-years. Even in the most isolated regions of the Milky Way, you are never more than a few hundred light-years from the nearest star. The galaxy is populated. Even its emptiest volumes are not truly empty of stellar light. Now move further. Leave the Milky Way. Cross the Intergalactic Medium, the extraordinary emptiness between galaxies that we explored in another journey. Arrive at a galaxy far from the dense cluster environments where most large galaxies live. Here, things begin to feel different. The sky changes. The Milky Way is no longer overhead. It is behind you, a faint elliptical smear, its hundreds of billions of stars reduced by distance to a collective glow barely distinguishable from other faint galaxies in the field of view. And the nearest galaxies, your new neighbors, are millions of light-years away. This is a different kind of isolation. Not the isolation of being between stars, but the isolation of being between galaxies. The night sky here is sparse in a way that the sky as seen from Earth is not. But even here, we have not yet reached the loneliest place. We have to go further, into a specific type of cosmic environment that represents the extreme end of the isolation scale. We have to go into a void. The universe is not uniformly populated with galaxies. They are clustered, packed together in groups and clusters and superclusters along the filaments of the cosmic web. And between the filaments are the voids. Enormous regions of space, hundreds of millions of light-years across, that are nearly empty of any galaxy or structure. The voids are the universe's deserts. But where Earth's deserts have an atmosphere and occasional life and borders beyond which forests grow, the cosmic voids have almost nothing. And their borders, the filaments of the web, can be hundreds of millions of light-years away. Inside a void, galaxies are not entirely absent. They exist, void galaxies, isolated wanderers that somehow settled in the empty spaces between the web structure rather than being incorporated into clusters or groups. But they are rare. Where the dense regions of the cosmic web contain thousands of galaxies per unit volume, the voids contain only a handful. These void galaxies are the loneliest large structures in the observable universe. They are galaxies that have been alone for most of cosmic history, evolving in isolation, forming stars from their own gas reserves, with no neighbors nearby to interact with or merge with or steal gas from. The loneliest of them represent the most isolated large objects in the observable universe. But even these galaxies are not the loneliest place, because inside a galaxy, even a lone galaxy in the middle of a void, there are hundreds of billions of stars. There is structure. There is the ordinary business of stellar physics, gas clouds, star formation, the constant activity of a system that has been building for billions of years. The loneliest place is not a galaxy. The loneliest place is something smaller, something that exists not in the dense heart of a galaxy but at the extreme periphery, something that has been pushed to the very edge of any possible neighborhood, a place where the nearest star is not light years away, not hundreds of light years away, not even thousands of light years away, a place where the nearest star is tens of thousands of light years away, a place in the halo of a galaxy so remote that the galaxy itself is barely aware of it. We are looking for what astronomers call intergalactic stars, or more precisely, the most isolated of them. Stars that exist outside galaxies are not hypothetical. They have been discovered, observed, cataloged, and among them, some occupy positions so extreme that they challenge the definition of stellar neighborhood. The story of how stars end up alone in intergalactic space is a story of violence at cosmic scales. Galaxies, over their histories, interact. They approach each other, their gravitational fields reaching across millions of light years to pull at each other's structure. They merge, two galaxies colliding over billions of years in a slow gravitational dance that eventually combines them into a single, larger galaxy. They strip each other, passing close enough that tidal forces tear stars from one galaxy's outer edges and fling them into the surrounding space. During these interactions, stars can be ejected, not gently nudged onto wider orbits but violently flung, accelerated to velocities that exceed the gravitational escape velocity of their parent galaxy, sent outward on trajectories that will carry them away from any galaxy into the intergalactic medium forever. These are runaway stars, stars that were once members of a galactic community, embedded in a spiral arm or an elliptical halo, and are now alone, moving through intergalactic space at hundreds of kilometers per second, heading nowhere in particular, burning through their fuel in the dark. Some of these stars end up in the halos of galaxy clusters, the diffuse outer regions of the enormous gravitational structures that form where multiple galaxies have come together. Galaxy clusters have been found to contain significant populations of intracluster stars, stars that do not belong to any individual galaxy, but instead orbit the entire cluster's gravitational center. These intracluster stars are isolated by normal stellar standards. Their nearest stellar neighbor might be light years away even within the cluster's halo, compared to the fraction of a light year that separates the Sun from its nearest neighbors in the crowded galactic disk. But the most isolated stars of all are not in cluster halos. They are the ones that escaped entirely, the ones that were flung not just out of their parent galaxy but out of any galaxy cluster, out into the intergalactic voids. These stars, traveling alone through the deepest voids of the cosmic web, are the most isolated individual stars known to exist, and their situation is extraordinary. Imagine being one of these stars. You were born in a galaxy billions of years ago, a galaxy with hundreds of billions of neighbors, a galaxy with spiral arms full of young blue stars, with a dense central bulge of old red stars, with gas clouds and star clusters and all the ordinary business of a stellar community. You lived there for millions or billions of years, and then something happened. Your galaxy collided with another. The gravitational disruption of the merger sent waves through the stellar distribution, chaotic and violent. And in the chaos, a gravitational encounter, perhaps between you and a pair of other stars, a three-body interaction that ejected one at high velocity, flung you outward. You accelerated. Your velocity increased beyond the escape velocity of the galaxy. You crossed the outer halo, leaving behind the familiar structure of your home. You entered the intergalactic medium, and then the acceleration stopped. You were on a ballistic trajectory, moving through the void at whatever velocity the ejection had given you. Perhaps 500 kilometers per second, perhaps 1,000, fast by human standards, agonizingly slow by cosmic standards. And around you, nothing. The galaxy you came from is growing smaller behind you. The nearest other galaxy is millions of light years away. The temperature of the space around you is 2.7 Kelvin. The density of matter is 1 atom per cubic meter. You are burning hydrogen in your core, generating light, a point of radiation in the middle of a void that contains almost no other light sources. No one can see you. No planet orbits you close enough for your light to matter. No other star is near enough for your gravitational influence to be felt. You are radiating into a void so large that your light will travel for millions of years before encountering any matter dense enough to interact with. You are the loneliest star in the universe, and you have no idea. Let's go even further into the isolation, because a star, however alone it may be, is still a burning engine, still an active, energetic object with a future, however dim and solitary that future may be. Still, in principle, warm enough to maintain a planetary system. Still capable, if it has planets, of providing the energy that allows liquid water and chemistry and potentially something like life. The loneliest star is lonely, but it is not dead. What about something further along the evolutionary track? What about the remnants of stars that have already burned through their fuel and died? The cold, dark objects that remain when the fires go out? White dwarfs are the remnants of stars like the Sun. After the red giant phase, after the planetary nebula dispersal, the core contracts to a dense object roughly the size of Earth, supported against further collapse by the quantum mechanical pressure of its electrons. It glows, initially very hot, cooling over billions of years, but it generates no new energy. It is simply radiating away the heat it accumulated during its stellar lifetime. In billions of years, a white dwarf cools to a black dwarf, an object at the temperature of the surrounding space, emitting no significant radiation, detectable, if at all, only by its gravitational influence on anything nearby or by the faint thermal emission of its cooling surface. A black dwarf in intergalactic space, in the void, far from any galaxy, would be the most isolated cold object in the universe. No nearby stars, no nearby planets, no interstellar medium dense enough to provide any material for interaction. Just a cold, dark, dense sphere of crystallized carbon and oxygen, moving through the void at whatever velocity it inherited from the stellar encounter that ejected it billions of years ago, moving toward nothing in particular. For an eternity, the universe does not yet contain true black dwarfs. White dwarfs take longer to cool to black dwarf temperatures than the current age of the universe. The oldest white dwarfs are still warm enough to emit faint radiation. The first true black dwarfs will not form for trillions of years, but they will form, and some of them will form from white dwarfs that were already in the intergalactic void when they cooled, already alone, already on their trillion-year journey toward complete thermal equilibrium with the surrounding space. Those future black dwarfs will be the loneliest objects the universe has ever produced. Cold, dark, essentially invisible, moving through the deepest voids in complete silence. Not dead exactly, still there, still massive, still influencing, through gravity, anything in their immediate vicinity, though their immediate vicinity contains essentially nothing. Just there, in the dark, forever. The thought is not horror. It is something quieter than horror. The specific weight of something that exists beyond the reach of any possible connection. Now let's step back and think about what we have found so far. We have traveled from Earth outward through layers of cosmic structure, from the solar neighborhood, through the galaxy, across the intergalactic medium, into the voids. We have found that isolation increases at every step, that the familiar structures, the stars, the galaxies, the clusters, become sparser and more distant as we move outward. And we have found specific candidates for extreme isolation. The void galaxies, evolving alone for billions of years. The intergalactic runaway stars, ejected from their home galaxies and now burning alone in the void. The future black dwarfs, cooling through the eternity of the dark. But there is a perspective we have not yet considered. One that is not about the most isolated object in the universe, but about the most isolated vantage point. The place from which the experience of loneliness, if experience is the right word, would be most acute. And that perspective changes the question in a way that makes the answer even stranger. We have been asking, where is the most isolated thing? But perhaps the better question is, from where does the universe look most empty? Because these two questions have different answers. The most isolated object, the loneliest individual thing in the observable universe, might be a runaway star or a future black dwarf in a void. But the vantage point from which the universe looks most empty might be somewhere else entirely. It might be from inside the largest known void. It might be from inside the Boötes Void. The Boötes Void is 330 million light-years across, nearly empty of galaxies, a sphere of near-nothingness carved into the cosmic web 700 million light-years from Earth. A handful of galaxies exist within its boundaries, perhaps 60, in a region where the surrounding universe would typically contain thousands. These galaxies are not evenly distributed through the void. They cluster slightly. Gravitational instability will always find ways to form small groups even in the emptiest environments. But they are sparse beyond any ordinary astronomical description of sparse. From inside the Boötes Void, from a planet orbiting a star in one of those 60 galaxies, the sky would be extraordinary. Not extraordinary in the way the Hubble Deep Field is extraordinary. Packed with thousands of galaxies in every direction, a universe overflowing with structure. Extraordinary in the opposite sense. The sky would be almost empty. Some analyses suggest the supervoid is approximately 300 million light-years across, comparable to or larger than the Boötes Void. Others suggest it is even larger, perhaps the largest structure ever identified in the observable universe. If the supervoid in Eridanus is real, if it corresponds to the largest void yet found, then it represents the extreme end of cosmic emptiness. A region of space so large, so empty, and so isolated from the surrounding cosmic web that its gravitational signature is visible in the oldest light in the universe. A civilization inside the supervoid would look out at a sky even more sparse than the sky from inside the Boötes Void. They would live in the most isolated cosmic neighborhood in the observable universe. They would be, quite literally, in the loneliest place we know of. But let's take one more step outward, because even the Eridanus supervoid, even the loneliest large-scale neighborhood in the observable universe contains galaxies, contains stars, contains, presumably, planets. And planets, given the right conditions, can harbor life. The loneliest inhabited place in the universe is not defined only by the density of the surrounding cosmic structure. It is defined by the intersection of that structure with the circumstances of the individual observer. And the loneliest observer in the universe might be on a world that is not in a void at all. It might be on a world that is in the right galaxy, in the right star system at the right time, but separated from any other world by a circumstance more fundamental than distance. Let us think about this for a moment. On Earth, we have been broadcasting electromagnetic signals into space for roughly a century. Radio waves, television signals, radar pulses, all expanding outward at the speed of light, reaching further into the galaxy with every passing year. By now, our signals have reached roughly 100 light-years from Earth, a sphere of space containing perhaps a few thousand star systems. We have also been listening. SETI, the search for extraterrestrial intelligence, has been scanning the radio sky for signals from other civilizations since the 1960s. Decades of listening. Some candidate signals detected, none confirmed. No unambiguous message from another intelligence has ever been received. This silence has many possible explanations. Perhaps other civilizations do not use radio. Perhaps our searches have been too narrow, looking for the wrong kinds of signals. Perhaps intelligent life is rare and the nearest civilization is thousands of light years away, its signals too faint to detect. Perhaps intelligent civilizations routinely destroy themselves before developing the capability for interstellar communication. But there is another possibility that is rarely discussed directly. Perhaps the loneliest civilization in the universe is not in a void. Perhaps it is simply the first. The universe is 13.8 billion years old. Complex life on Earth has existed for perhaps 600 million years. Technological civilization capable of interstellar communication has existed for less than a century. We may be extraordinarily early. We may be among the first technological civilizations to develop in the observable universe. If we are early, if intelligent life is still rare because the universe has not had time to produce much of it yet, then the nearest civilization might be far away not because of voids or isolation but simply because of timing. because not enough time has passed for the universe to fill with minds. A civilization that is first, that develops intelligence before any other civilization within communication range, would not know it was first. It would look at the sky and see the same silence that we see. It would search for signals and find none. It would wonder whether the absence of response means anything. And the answer, if it is first, is that the absence means everything. It means the universe has not yet produced anyone else within range. This is a different kind of loneliness than the loneliness of a void galaxy or an intergalactic star. It is not spatial isolation. It is temporal isolation. Being alone not because nothing surrounds you, but because nothing has yet developed around you. The loneliest civilization in the universe might be the earliest one. And the earliest one would have no way of knowing whether it was early or simply unlucky. We do not know which we are. Let's step away from speculation and return to something certain. The universe has a specific feature that guarantees the existence of extreme loneliness at the largest scales. It is a feature we have discussed before, but in the context of loneliness, it takes on a particular weight. The accelerating expansion of space. The universe is expanding. Every galaxy is moving away from every other galaxy, not because the galaxies are moving through space, but because space itself is expanding. And the expansion is accelerating, driven by dark energy, the mysterious force that dominates the universe's energy budget. The expansion is not slowing down, but speeding up. This has a consequence that is, in the context of loneliness, devastating. Every galaxy in the observable universe is receding from every other galaxy. Most of them are receding fast enough that light from them is redshifted, its wavelength stretched by the expansion of space during the journey from source to observer. The most distant galaxies we can observe are receding from us faster than the speed of light, not because they are moving through space at superluminal speeds, which is impossible, but because the space between us and them is expanding at a rate that adds more than a light year of distance per year to the gap. These galaxies are, in a fundamental sense, already beyond reach. We can see their past, the light that left them long ago, before the expansion carried them so far away. But we can never send a signal that reaches them. We can never receive a signal from them that was sent after a certain moment in their history. The expansion has separated us permanently. Now think about what this means over billions of years. As the universe ages and the expansion continues, more and more galaxies will recede beyond the cosmological horizon. Galaxies that are currently observable will gradually fade from view, not because they stop existing, but because the space between us and them expands faster than their light can cross it. Their future emissions will never reach us. In the far future, in the universe of the distant cosmic epochs, individual galaxy groups will become isolated islands. The local group, the collection of galaxies that includes the Milky Way and Andromeda and their smaller companions, is gravitationally bound. It will not be torn apart by the expansion, but everything beyond the local group will gradually recede beyond the horizon. A future civilization in the far future universe will look at the sky and see, instead of the 2 trillion galaxies that we observe today, only the galaxies of the local group. Everything else will have receded beyond detection. That future civilization will be cosmologically isolated, not because they are in a void, not because they have been ejected into intergalactic space, but because the universe has expanded to the point where the rest of the cosmos is no longer accessible. They will be alone in the most final sense, not separated from the rest of the universe by distance that could in principle be crossed, but separated by the geometry of an accelerating expansion that places the rest of the universe permanently beyond any possible communication. And they will look at the sky and wonder why it is so empty. The answer, that there is an entire universe beyond the horizon that they can no longer reach or even see, will be available to them only if they have records from an earlier epoch, from a time like now, when the universe was still young enough for its full extent to be observable. If those records survive, if they have chosen to keep them, the loneliness of the future universe raises a question about the present that is worth sitting with. We are alive in the most favorable cosmological epoch for understanding the universe. The cosmic microwave background is still detectable. Galaxies are still within observational range in numbers that allow the cosmic web to be mapped. The evidence for the Big Bang and cosmic expansion is abundant and clear. In the far future, much of this evidence will be gone. The microwave background will be redshifted to wavelengths too long for any physical instrument to detect. The distant galaxies will have receded beyond the horizon. The observable universe will appear to consist of the local group alone. Future astronomers, if any exist, will have a much harder task understanding what the universe is. They will look at a sky that seems to contain only a handful of galaxies and struggle to reconstruct the cosmological model that we take for granted. In a sense, we live at the privileged moment. The moment when the universe's history and extent are still readable. When the evidence is still visible. When the full complexity of what exists, the cosmic web, the voids, the trillions of galaxies, the ancient radiation of the Big Bang, can still be observed and understood. This privilege is not permanent. It will erode. As the universe ages, the observational record will thin. The evidence will fade. The sky will empty. We are the universe knowing itself at the moment of maximum clarity. Everything after this will be, in some sense, less clear, more isolated, more alone. The loneliness of the universe is increasing. Not for us now, not yet, but the direction is set. The dark energy is accelerating the expansion. The horizon is shrinking in the sense that fewer and fewer galaxies remain within it. The universe is becoming more solitary, more isolated, more quiet, not quickly, on timescales that dwarf the current age of the universe, but steadily. Inevitably, the universe's loneliness is its future. Now let's return to the specific, to the individual, to the question of the loneliest place not as an abstract cosmological concept, but as a real location where a real observer might exist. What would it feel like, if feeling is the word, to be the loneliest observer in the observable universe? Let us place ourselves there. On a hypothetical world orbiting a hypothetical star in the most isolated location we have identified. A galaxy deep inside a void as large as the Eridanus supervoid, billions of light years from the densest regions of the cosmic web. You wake in this thought experiment to a night sky that bears no resemblance to the sky above Earth. There is no Milky Way, no band of light stretched across the darkness from horizon to horizon. Your galaxy is there, you live inside it, so its stars are present in the sky as they are in ours. But the band is fainter, perhaps. Your galaxy is isolated, smaller than the Milky Way with fewer stars. The band of galactic light is thinner. Look outside the galaxy. Look at the deep sky. In every direction, almost nothing. In the direction of the void's nearest boundary, the nearest filament of the cosmic web, there are faint hints of distant galaxy clusters. Smears of ancient light, barely detectable, representing galaxies hundreds of millions of light years away. In most other directions, nothing visible at all at the distances where we can see abundant galaxies from Earth. The sky is quiet in a way that Earth's sky, even on the darkest night, never is. Your civilization, assuming your world has developed one, has built its cosmological model from this sky. It has measured the cosmic microwave background and found it just as uniform, just as ancient as ours. It has detected the expansion of space from the redshifts of those few distant galaxies. It knows the universe is 13.8 billion years old, that it began in a hot, dense state, that it is expanding and cooling. But when it looks for the cosmic web, when it tries to map the large-scale structure of the universe, it finds primarily the void it lives in. The web is there at the boundaries, but sparse in the observable volume. The picture of the universe from inside the supervoid looks emptier than the universe actually is. Your astronomers argue. Some say the universe is truly sparse, that the cosmic web is a feature only of the densest regions and that most of the universe is void. Others trust the cosmological model, which predicts more galaxies than they can see, and conclude they must be living in an unusual location. The debate takes decades. Eventually, the model wins. The evidence from the microwave background is too strong, the physics too clear. They are in a void. The rest of the universe is out there. But knowing this intellectually does not change what the sky looks like. The sky is still quiet. The universe visible from their world is still sparse. The experience of the cosmos, the felt experience, if a civilization can be said to feel its cosmological situation, is one of unusual isolation. They live in the loneliest neighborhood in the observable universe. And unlike a human being who feels lonely in a crowd, they cannot simply move. They cannot choose a different cosmological location. They are where they are in the void for the entire duration of their civilization's existence. Their loneliness is not chosen. It is simply where they were born. Let's think about what this means for the question of life and intelligence in the universe. One of the factors that some scientists have proposed as relevant to the development of intelligent life is the density of the cosmic neighborhood. A world in a galaxy cluster, surrounded by many galaxies, experiences a richer environment than a world in a void galaxy. More galaxies means more stars, more planets, more chances for life to develop, more potential for the exchange of materials between stellar systems, and, hypothetically, more opportunity for civilizations to detect each other and be motivated to develop communication technology. By this reasoning, the loneliest civilizations, those in void galaxies, those furthest from the dense web of structure, would not only experience cosmic isolation but might experience it in their culture and philosophy as well. A civilization that has never detected any evidence of another civilization, whose sky is empty of the galaxy clusters that might suggest a populated cosmos, might develop a very different understanding of their place in the universe than we have. They might conclude they are alone, not as an open scientific question the way we hold it, but as a settled fact of their cosmological situation. The sky, in every direction, offers no evidence of anyone else. The nearest galaxy is tens of millions of light years away. The chance of receiving any signal from it, let alone a signal from an intelligent civilization within it, is essentially zero on any timescale their civilization has existed. They might be right. They might be alone in their void. The handful of galaxies within their reach might contain no other technological civilizations. And the civilizations that exist, billions of light years away in the densely populated filaments of the cosmic web, might as well not exist for all the difference they make to a civilization trapped in the void. Or they might be wrong. The void might contain another world, another civilization, as isolated as their own, as convinced of their solitude, as yet undetected. Two isolated civilizations in the same void, each convinced they are alone, separated by millions of light years, never knowing the other exists. The loneliness of the void is not necessarily absolute. It is simply vast enough to make the alternative seem impossible. Now let's visit the loneliest individual object we know of. Not a place in a void, not a future black dwarf, not a void galaxy. A specific, observed object with a known position in the universe. A star called HIP 85605. Wait, that is not quite right. Let me take you instead to something more dramatic. Let me take you to the fastest moving stars in our own galaxy, the hypervelocity stars. Hypervelocity stars are stars that have been accelerated to extraordinary velocities, in excess of the galaxy's escape velocity, by encounters with the supermassive black hole at the center of the Milky Way. The black hole at the galactic center, with a mass of 4 million suns, has an extraordinary gravitational influence on stars that pass close to it. When a binary star system passes too close to the black hole, a three-body interaction can eject one of the stars at enormous velocity, hundreds or even thousands of kilometers per second, while the other star is captured. The ejected star, a hypervelocity star, travels outward from the galactic center at escape velocity or faster. It crosses the galaxy's disk, exits the spiral arms, passes through the outer halo, and then leaves the galaxy entirely. It becomes an intergalactic star. Some hypervelocity stars have already left the Milky Way. Others are still within the galaxy but on clear exit trajectories. And in millions of years, they will be alone in the intergalactic medium, moving through the void at hundreds of kilometers per second, heading toward no particular destination. These stars carry with them, in their velocity and their chemical composition and their spectral properties, a record of where they came from. Astronomers can measure their trajectories backward through time and identify that they originated near the galactic center. They are, in a very real sense, refugees, objects ejected from their home environment by one of the most violent processes in the galaxy. And their future is solitude. For billions of years, potentially for the entire remaining lifetime of the universe, they will travel alone through the intergalactic void. No planet orbits them. No companion star shares their trajectory. No galaxy will claim them. They are simply moving, alone, through the dark. The loneliest stars we know of are the ones the universe has expelled. There is something in this story, the story of the loneliest places in the universe, that has been building quietly through every section. The universe tends toward isolation, not in the way that might be immediately obvious. Not by being empty, it is not empty as we have seen. The cosmic web is rich with structure. Galaxies contain hundreds of billions of stars. Planetary systems are common. The universe is, in its populated regions, extraordinarily full. But full is not the same as connected. And connected is not the same as close. The overwhelming majority of the universe by volume, by extent, is the between. The void, the intergalactic medium with its 1 atom per cubic meter and its 100 million degree plasma that conveys no warmth. The deep space between the galaxies where even the light that fills it is ancient and dim. And within the galaxies themselves, between the stars, the same pattern continues at smaller scale. Mostly emptiness, mostly distance. The rare exceptions, the dense star-forming regions, the globular clusters, the galactic centers, are dramatic precisely because they are exceptions. The universe's default state is isolation. What makes life possible, what makes any of the rich, complex, connected world of biology possible is the exception. The warm planetary surface, the liquid water, the proximity to a stable star, the chemical richness produced by billions of years of stellar nucleosynthesis. These are not the universe's ordinary state. They are extraordinary conditions that exist in specific places, under specific circumstances, for specific periods. We exist at the exception. In a solar system that is extraordinarily ordinary by stellar standards but extraordinarily rare by universal standards. On a planet that is, as far as we know, the only place in the observable universe currently producing beings who wonder about the loneliest place in the universe. This is not cause for despair. It is cause for attention. For the specific quality of attention that the contemplation of loneliness and scale produces, the quality that reminds you what you have by showing you how much could not be there. The universe's loneliness makes our particular form of connectivity, biological, ecological, social, emotional, seem less like an ordinary condition and more like an achievement. The universe tends toward isolation. We, for now, resist it. The question we started with, what is the loneliest place in the universe, does not have a single clean answer. The loneliest vantage point is inside the largest supervoid, where the sky is most empty and the cosmic web is most distant. The loneliest individual objects are the hypervelocity stars and future black dwarfs moving through the intergalactic medium with no galaxy to call home. The loneliest neighborhood is the void galaxy that has evolved in isolation for billions of years, with no neighbors near enough to interact with. The loneliest possible circumstance is a civilization that is temporally first, alone not in space but in time, waiting for a universe that has not yet filled with minds. And all of these forms of loneliness are real, not hypothetical, not theoretical. The voids exist and have been measured. The hypervelocity stars have been observed. The void galaxies are catalogued. The timing question, whether we are cosmologically early, is an open scientific problem. The universe's loneliness is not an abstract concern. It is the dominant feature of everything outside the narrow exceptions where matter has clustered and complexity has assembled. The loneliest place in the universe is most of it. And the question of loneliness, of what it means to exist in isolation, To burn or orbit or drift in the dark without any nearby witness, without any neighboring structure that could care whether you are there, is ultimately a question about meaning, about whether the universe's scale makes existence significant or insignificant. The answer, if there is one, is not in the voids. It is in the fact that the question is being asked. The universe does not ask questions about its own loneliness. It does not wonder. It does not care. The void is not lonely in the way a person is lonely, because the void has no interior life. The hypervelocity star traveling through the intergalactic medium does not experience its isolation. The future black dwarf, cooling to absolute zero in the dark, has no awareness of what surrounds it. Only we do. Only something that can wonder can experience the weight of cosmic isolation. And because we can wonder, because we can stand on a pale blue dot in the spiral arm of an ordinary galaxy and contemplate the loneliness of the supervoid and the intergalactic stars and the void galaxies and the far future of a darkening universe, we are, in some sense, doing something that no other part of the universe is doing. We are keeping the universe company, not all of it, not the parts that are too far away to know we exist, but the universe in our vicinity, the local group, the nearby cosmic web, the ancient radiation that fills our sky, is known to at least one conscious observer. That is not nothing. It is, in a universe that tends so strongly toward isolation, something close to extraordinary. The night sky above you right now is full of light. Not just the stars, though they are there, the familiar patterns of constellations that have guided human navigation and imagination for all of recorded history. Not just the planets, though they are there too, moving slowly through the zodiac on their own schedules. Not just the faint smear of the Milky Way, if you are somewhere dark enough to see it. There is light from galaxies that you cannot see with the naked eye. Light that has been traveling for millions of years, crossing the intergalactic medium, arriving at Earth tonight, entering the atmosphere and scattering through the sky. There is the cosmic microwave background, too diffuse to see but present, filling every direction, touching the atmosphere, warming the universe by a fraction of a degree above absolute zero. There is ancient light all around you, light from objects that existed before the Earth, before the Sun, in some cases before the solar system's parent stars had formed. Light that has crossed voids and filaments and the hot plasma of galaxy clusters and arrived here, tonight, at this atmosphere, at these eyes. The universe has been sending light toward Earth for 13.8 billion years. And somewhere in that light, somewhere in the photons arriving from the direction of the voids, from the direction of the isolated galaxies, from the direction of the most sparse and empty regions of the observable cosmos, is the light of the loneliest stars, the hypervelocity stars moving through the void galaxies burning alone in their empty neighborhoods. The faint radiation of the most isolated objects the universe has produced. That light has traveled, in some cases, for billions of years to reach you, and you, for a moment, are receiving it. In the geometry of light and observation, in the physics of photons traveling across the universe and arriving at an eye that can record their presence, you and the loneliest star are briefly connected. Not close, not in any meaningful spatial sense, but connected by the simplest possible link the universe offers. Light leaving one place and arriving at another, a signal from the isolated to the present. The loneliest stars are not witnessed by anyone in their immediate vicinity. There is no one near enough to see them, but we see them. Their light, redshifted and dimmed by distance, arrives here and enters telescopes and is recorded in images and spectra and eventually understood. The universe's loneliness is not invisible. It is accessible. From far away, through the medium of ancient light, we can know where the emptiness is deepest. And knowing it, contemplating it, following the logic of isolation to its extreme conclusions, is one of the most distinctly human things we do. We look at the loneliest places in the universe and feel something. Not their loneliness, we feel our own version of it, the human version, the version that comes with consciousness and connection and the knowledge of what it would mean to be cut off from both. We feel something, and the feeling is the point. For those still listening, my biggest goal on this channel is to reach 1,000 subscribers. So if you enjoy falling asleep to my videos, please hit that subscribe button. There is a star out there, moving through the intergalactic void, probably expelled from a galaxy billions of years ago by a three-body encounter near a supermassive black hole that has been alone for longer than the Earth has existed. Its light has been traveling outward in all directions, into the hot plasma of the intergalactic medium, into the void where almost no matter exists to interact with it. In every direction, across distances so large that even the light of a star fades to nothing before encountering another object. That star has no knowledge of us, no concept of Earth or of the small planet that has produced, against all cosmic probability, beings who wonder about its loneliness. But we know about it. We have seen its kind. We have measured the trajectories of hypervelocity stars, calculated how long they have been traveling, estimated how far they have come. We have extended those calculations into the future and understood what awaits them. The slow cooling of their stellar furnace, the eventual expansion into a giant, the dispersal of their outer layers, and then the long silence of the white dwarf cooling through the eternal dark. We know what we cannot reach. We know the loneliness we cannot visit. And knowing it, from our warm and crowded corner of the universe, from this planet with its atmosphere and its oceans and its incomprehensible biological complexity, knowing it changes something. Not permanently, not in a way that rewrites ordinary life, but in the small hours of the night, in the moments between waking and sleep, the knowledge of the void sits quietly in the mind. The universe is mostly empty. We are in the exception. The exception is temporary, and while it lasts, it is everything. Sleep well.